Welcome. First session of the day, day 3. How are we feeling? Good. I wish I was feeling like that. Bit tough getting up after last night's fun. But anyway, here we are. This is our Microsoft SQL Server Analysis Services Design Challenges, a level 300 session. So I'm interested to know from the audience, by show of hands, who is already working with analysis services? I'm hoping that's the entire room. Anyone left over? Okay, obviously you're welcome to stay. This session really should be extending beyond the basic design skills that you may have already accumulated. So certainly stick around. But we're really targeting an audience that perhaps have gained some proficiency at building cubes, but are looking to take their skills to the next level, to build more optimized, feature-rich designs. So a bit of introduction about myself. I'm a mentor with a global partner called SolidQ. 14 years experience working with Microsoft data platforms, of which I've been working with analysis services since the 2000 release. So that's probably coming up to just over 10 years. And I pretty much spend most of my time these days either building content or delivering training around it. I think I've built most cubes that I want to build. It becomes more interesting actually sharing my experiences with audience like this and customized training and classrooms. I'm based in San Francisco, but you might detect an accent. I'm actually Australian and have been living here for the past 2.5 years. So my email address is included here. Should there be any follow-up questions in relation to the material that I present today, you're most welcome to either contact me here at the end of the session. Perhaps if you're watching this through the recording, you're welcome to reach out to me at this email address here. Okay, so the agenda for this session. I think it's good to review the UDM fundamentals to begin with to make sure we're on the same page. And very much this is about addressing particular design challenges. So I'm going to take a look at topics of the source schema design itself, the data source views, dimensions, cubes, cube calculations, cube enhancements, and security. And there'll be demonstrations that I'll interleave between those topics. So to be clear about the session objectives, this is about covering best practice design for dimensions and cubes, and also addresses common design challenges in relation to supporting source schema design, cube calculations, and security. So arguably, and I have this with my colleagues and students, is, what is best practice? And of course it will depend. Best practice is really more of a guideline, and depending on the particular challenges that you face, what we ask you to do is to be somewhat analytic in solving the problems you have. Don't just say that this is the way I saw it done, so therefore that's the way it's going to work for me, because it may not be the fit. You really have to understand the circumstances, test, try, retest, and so on, reject what doesn't work in a particular situation, accept what does, and move on. So I'm just saying that what I present here may not necessarily be the fit, but it's thought-provoking nonetheless. Sometimes too, when I looked at this, the best practices tend to become tips as well. So there's this blurred line as to whether this is a good practice you should follow versus this is just something that's going to make your life easier. So sometimes some of the topics and the examples I use will fall into that category. So this session is about good modeling techniques with an aim to produce a feature-rich and optimized unified dimensional model. Adding business logic with MDX, but please note this is not an MDX session, so it's going to cover some practices and tips and tricks. We'll talk about security with the UDM and some common challenges that people face, particularly with authentication, dynamic security. To be clear, this session does not directly cover the storage layer. So partitions, storage modes, aggregation design, or processing, there is actually another session this week here at TechEd that addressed that more directly. There's only so much you can cover in 75 minutes adequately. So the 2 sessions that address analysis services cube design, we pretty much ensure that the topics were evenly shared between the 2. So I know it was yesterday's session. I'm hoping if that's relevant, you did get to see it. Otherwise, you can follow through with the recording. And that was the DBI 407, Best Practices for Building Tier 1 Enterprise BI Solutions with Analysis Services by Adam Jorgensen. A word about AdventureWorks. So, in case you've never been introduced to it, it's a fictitious company upon which the AdventureWorks sample databases and tutorials are based. And so I'm going to start by saying that these samples are good. Good for learning about designing and what the Analysis Services UDM can do for you, and great, in fact, for supporting a series of tutorials, labs, and demonstrations. This was my first introduction to the UDM during the Yukon phase of the project back in, I think, 2004. Okay, but the samples are also bad. You may have discovered this for yourself. Bad for learning best practice design. Worse, in fact, for using as a template for your own UDMs. Has anyone discovered this? So actually, I think it's helpful to demonstrate from AdventureWorks and pick it apart and perhaps point out where we could do better with the design that ships with the samples. Okay, so let's start with reviewing the UDM fundamentals. This is just setting the page. Core to good cube design is actually the focus on good dimension design. The cube part is relatively straightforward if your dimensions are good. All right? So we often find as developers we spend most of our time designing, developing, optimizing the dimensions, and then assembling a cube from these optimized structures to produce, in turn, an optimized cube. So dimensions, as we probably all appreciate, are attribute-based, so collections of attributes. We can decide whether those attributes will expose hierarchies, and that supports the ability to browse the membership and slice and dice the related measures that we have. We can introduce hierarchies then that consist of multi-levels, because these attribute hierarchies are quite shallow. At most, an all member and a level beneath it, consisting of the distinct values found within our key columns. These hierarchies support much better navigation, multi-level like year to quarter to month to day. And what we discover is that these levels are actually just an ordered sequence of our attribute hierarchies to provide this navigation experience. The key part about this then are the attribute relationships. The attributes themselves in the dimension have to relate to themselves at some point. There's what we call the key attribute. Think of it like the primary key of a table in a relational world. And essentially all other attributes have to have some relation to it directly or indirectly. And it's still a lesson that I discover has to be reinforced with my students and customers. Okay, so these are standalone objects in the database. We create them, optimize them. They're available for reuse in multiple cubes. So then we can build this cube, which consists of a measure group or measure groups, loosely relating to the fact tables that we have in our schema. And that's where we find our measures, these numeric columns that we aggregate, typically with sum, count, and other aggregate functions, and this is what we're analyzing. The storage for measure groups are partitions. And then we introduce these cube dimensions that are instances of the database dimensions. And this is what builds up this model. Measures actually forms the backbone or the very first dimension of our cube, and the cube dimensions that we add then enrich and extend and build this multi-dimensional structure. Cube attributes and cube hierarchies allow us to override and optimize the properties that we have in the underlying database dimensions for a particular cube instance. And then finally, to complete this diagram, some relationship, if indeed there is a relationship, between our measure group and our cube dimensions. So it's sort of understood that this audience already has a grasp on this. Is that reasonable? All right, there's our 2-minute review of the UDM. Just out of interest, who's been following the BI semantic model this week? In particular, what's now known as the tabular BI semantic model. Because when you present this, particularly to a developer or a relational database developer, this is overwhelming. Just give me tables, give me columns, give me relationships to build what I need. I don't need to learn about all this intricacy and complexity. And so that's why the BI semantic model in tabular form and Power Pivot, as you may be familiar with it, was born. Was to be able to produce multidimensional structures, but not with this level of complexity. So for those of you that have mastered this, because there was a bit of a threat for some people with a misunderstanding about what this new BI semantic model meant, does that mean all of my skills are now redundant? Well, no, there will always be a place for this, and analysis services will continue to support what's known as the BI semantic model from a multidimensional development perspective. All right. MDX script is the last build here. So that, until we introduced the script, that was really the physical model that came from the data underneath. We could represent our dimension and fact tables through this structure. But then the creative part starts. The MDX script allows us to become creators in this virtual worlds, basically. We can create virtual space and control the calculations within the virtual space through this MDX script. We could speak for 2 sessions alone on what this MDX script could do for you. All right, but let's start focusing on particular challenges. I'm starting here with source schema design. So dimensional modeling techniques have evolved to become largely best practice. So my suggestion here is learn from the masters. There are good publications already out there, maybe some conflicting ideas. Choose the one that works for you. They work, just be consistent in your application of them. But some ongoing challenges that you might face include, well, do we materialize calculations in our fact table? For example, I have total product cost and I have sales amount in the fact table. Should I compute profit, materialize it in the fact table, and then build a base measure from it? We'll talk about that. Generally, you will get better performance for that. All right, so what we discover is when it comes to optimizing, there's often, or almost always, trade-off. And so the trade-off here would be that there would probably be more processing time and storage time on disk for this, but faster query time. That's a simple one to talk about. What about snowflaking? Do you think there's still a debate about whether it's good to snowflake dimensions or not? By snowflaking, we mean we normalize the dimensions, and yet some theorists will shudder by saying, well, hold on, no, this whole underlying schema should be denormalized to really optimize and improve the query response time, to avoid joins. Any good arguments to continue snowflaking? See, it depends on what textbook you read. Some will say that you should never do it, and others will give good reasons for it. And I've discovered from experience that there's sometimes just good reasons to do it. All right, for example, I like the fact that if I have category, subcategory product, that I have primary keys in each of those tables that allow me to have other fact tables at different levels of granularity. I could have a fact table at product level for my sales, but my budgeting happens at subcategory level. Now, if it's a denormalized table, there's no way that I can have, or with integrity, create a key that I could reference by that second fact table. So different fact tables with different granularity really like working with snowflake dimensions. It might just be that the source system stores it that way. So from an ETL perspective, it's simple. There's a trade-off. I've just saved time in my ETL development. Okay, cleaning up with junk dimensions. When you find you've got those dimensions that perhaps consist of one attribute that has few members in it, it's like that junk drawer you might have at home, that miscellaneous spot where you just throw everything together. So cleaning up a schema and also cleaning up then the UDM that you present to someone. You could have this junk dimension, don't call it that, that consists of miscellaneous attributes. All right, so I think that's a good tip. I've often seen that there's this impressive list of dimensions when I look at the metadata pane of a UDM, but oftentimes there's one, maybe two attributes in some of them. Okay, the idea here is that we could cross-join all possibilities and produce a single key that represents the different combinations we have, and then use that single key in a fact table, and then have this one dimension that represents this odd assortment of sort of semi-related attributes. Next one is the parent-child situation, so self-referencing relationships. Certainly we can work with these, we can produce parent-child hierarchies, but does anyone run into the problem that performance degradation sets in at a certain point? And do we understand why? So a couple of hands in the audience. Okay, and the fact that these parent-child hierarchies is really a recursive relationship of the key attribute of the dimension. And you do not get, between the all and the leaf level, you do not get aggregations to support the efficient querying at runtime. Okay, so what the answer is here, sometimes, and unfortunately, and perhaps painfully, is that you might need to naturalize that parent-child hierarchy out to become fixed levels. In fact, you have to create columns that represent, if it's an organizational chart, you know, here's my general managers and sales reps and so on. Anyone worked with Bids Helper? So a tool that you can download from Codeplex, I include a link here, extend the capabilities and features of Bids, and one of its capabilities is to go ahead and naturalize a parent-child hierarchy to support a more efficient design in your dimension. This point's an interesting one, you might need to reflect on it, and sometimes there is the need to stop thinking relationally and to start thinking multidimensionally. This sort of happens unintentionally when you begin to think MDX. Do you ever notice you cross that line sometimes? Stop thinking relationally, think multidimensionally. And so what I ask you to do here is be prepared to be creative. And I'm going to show you in the demonstration today an approach where we could solve it using the cube, or we could be more creative in the way we prepare our relational source data and then build a measure group from it to get a more efficient and easier response coming from a cube. So be prepared to think outside the square and inside the cube. Moving on to the data source view, and also in respect that perhaps as a cube developer you have absolutely no influence on that data source. Sometimes that's tough. The best you've got is read-only access, no permission to modify or create objects down there, but just consume what you have available to you. So your next best bet is that you can start doing things at the data source view level. First of all, Enterprise Edition does support the capability to introduce multiple data sources into a single data source view. And I really discourage this. I would hope that if you have the opportunity that you would pre-integrate data first into a single store. And that's what integration services is for. The main problem you have when integrating multiple sources, and while it's possible, I can bring this table and drag and drop and create a relationship to a table that's sourced from another data source, is that if there is a lack of integrity between the two, it can create unusual or seemingly inaccurate results through the cube. So far better to have a formalized ETL process that's going to cleanse and integrate the data, and I think that's always a good prerequisite for a cube. Integrated, cleansed, data ready to go. Next, the base data source view tables, what do we base them on? So if you read documentation and recommendations, they'll often say, well, you know what? A data source view table should be converted to a named query that's actually based on a view that's sitting in the underlying data source. So you have multiple layers of abstraction. And actually, I do prefer this. And if you do have that ability to create objects down in your data source, I think it is a great practice to go ahead and create views or user-defined functions. This will support better maintainability and reusability of logic. And that'll be my first demonstration in just a moment. Okay, because the moment you start baking queries into the data source view, and potentially a DBA identifies some slow-running queries, one of which is involved in the processing of one of your database objects. Well, he or she would love to add a hint to improve the performance of that query, but what hope do they have when that query is embedded into a data source view checked into some source control system? All right, not a great idea. It's far preferable that you abstract it into an object and then base your data source view table on that object. If building a UDM on top of an OLTP schema, again, not really recommended, but sometimes these are the requirements that we have, and that's the data source we have. So my approach here is to go ahead and create views that mimic a star schema. So my fact tables, my dimension tables, I create a UDF, a scalar UDF, that will convert a date column into that 4-byte integer. Take the year, multiply by 10,000, add the month, multiply by 100, add the day, and then you can convert date values on the fly. And in a sense, you could build up this star schema. Now, the good news about this is you don't have to create the star schema or perform an ETL. And this approach could be great for prototypes. And then if your cube gets the green light to move ahead, well, it might just be a matter of then producing that star schema, retrofitting the cube on top of it. With good planning and design, that could happen. This one is where AdventureWorks first lets us down. Define appropriate single column keys. While attributes and dimensions can be based on this key columns, note the plural, key columns, this collection that will uniquely define the membership of a hierarchy, we prefer you don't do it. Not only does it make your MDX really ugly and ungainly, have you noticed? Multiple keys. All right, but it's way more inefficient. It's far preferable to have a single key. And so what I suggest there is, instead of the AdventureWorks style of let's bring together calendar year and calendar quarter, 2 columns as the key columns. Multiply that calendar year by 10, add the calendar quarter, and then we have a single integer that uniquely represents an instance of a quarter within a year. Far more efficient and appropriate to build your attribute off it. Define appropriate labels for member names. And I suggest that you store these in the views or UDFs that you have down in the source system if possible. And my tip here is, because you really need to be very careful, that if you do modify these things, that you don't break the bindings with the data source view and the objects that are built on top of it. In particular with text data, with string data, that you do not change the length All right, so if you are going to alter that view because you decided to change the label, I always cast it explicitly to the length that I know is defined in the DSV. And that way I know if I ever go to edit it, that whatever my label should be, that hint is there that it should really not exceed those 100 characters. Consider pre-calculating or at least partially calculating values in the DSV. So I talked about that example in a fact table that we could materialize a new column, or it could be a calculated column in the table that would subtract the total product cost from sales. Well, you could do this at that level as well. And then, of course, name tables and columns in friendly terms, because at this point, the wizards are going to go ahead and use those names to go ahead and construct the different objects that you have, dimensions, attributes, measures, and so on. So it pays to get that right up front and to appreciate from an end user perspective what's going to make it clear and unambiguous to them when they interpret your model. All right, that's really more of a tip than a best practice. So let me switch across to demo mode. Okay, that's better. What we see before us here is a partially completed project based off our trusty AdventureWorks sample database for 2008 R2. It's based off the reseller sales and sales quota subject areas. And so the first thing I'm going to point out to you here is the reseller sales has a direct binding to the table underneath. And what I'm going to do is switch across to the data warehouse, and because I have permission to do this, I create a schema, UDM is the name I choose here, where I'm going to create objects that will support my UDMs. And then I go ahead and create this user-defined function. In that schema, I'm repeating the table name. That may or may not be a good practice, but note the parameterization here that allows me to start passing in the date range that I want to retrieve from this fact table. And then on top of that, I'm selective about the columns that I return. And also, I include a label here that could be useful to construct a dimension later on. So I'm going to go ahead and create this. And then I can switch back, right-click my table, replace this with a new name query. I still want it to be called reseller sales. Delete this reference to the underlying table itself, and then introduce from my functions this UDF. And then pretty much I want all columns. And I need to pass in some values, so I'm going to choose something that I know, was a long time ago, 1970, January, 31st of December 2099. I'm sure I'm going to capture all fact data. I'm not going to be concerned what happens in the next century. All right, and so now we have this direct binding to the UDF. Now the benefit I've got here is that we'll note in the cube itself that there are a number of partitions here as well. So for consistency, I'm going to come across and say, well, for this partition for 2005 data, same thing. In fact, what's going to be easier is I just copy this. Just give me all columns from the UDF between this date range. And that has got to be far easier than managing that complex statement we saw earlier. And with the added benefit that if I go and modify this UDF, it's just going to flow through. I add a new column, then all partitions will consistently get it, which, by the way, is a requirement. You can't have partitions, older partitions with a different structure to newer partitions. They must all have the same bindings. All right, and that pretty much becomes the template for all future partitions that I'll create for this measure group. And we'll see later on that I'll extend this UDF. And I can go ahead, just test that I can deploy and that builds. So the next object that I have to create is to support my employee dimension, again in the UDM schema. This time it's just a view. But note the addition, well, first note, I'm not including all of the columns that I have in the underlying table, just what's necessary for this model. And here I am casting to these 102 characters because I know that's the length that the DSV expects for that column. This is building up, what is it building up? It's building up a label that describes the employee. So I just want to point out to you in the AdventureWorks database, it has start date and end date columns. What do you think that suggests? When you're looking at a dimension table and you see those types of columns, it's screaming something at you. Yep, type 2, slowly changing dimensions. What it says is that when particular attributes are changing, the ETL process will detect these and it will expire the current version and insert a new version. The rule I've discovered in AdventureWorks is that when a salesperson relocates to a different sales territory, it will result in a type 2 change. Okay, and so what I think it's important is that the label that uniquely defines the surrogate key, the primary key of this table, should reflect a description of that employee. And so I've chosen to include within parentheses after their name the time period, the validity of this record. And that's what this label here is doing. And I'm choosing to call that the employee version and its name. Sometimes we want to analyze just what the employee did regardless of what territory they're in. So a label that we would use on top of the business key would simply be what their name is. Okay, so let's go ahead and create this view. So I must have just created it. We had success with the deployment, so I'm happy to see that. Come back to my data source view, my employee table, right click again. Replace this with a name query. And this time, just base it off the view. And give me all columns. Okay, the view is also good that I can introduce a where clause. I might change my mind later on. I don't want to filter on particular employees. Okay. Next topic, dimensions. So optimized dimensions are a prerequisite for an optimized cube. Is that a surprise? The cube really is that conceptual model that brings these optimized objects together. So the most important 3 topics for optimizing dimensions, does anyone know the first? No? Okay. Attribute relationships, so we covered on that this morning. What do you think the second might be? Okay. Attribute relationships. Any guesses for the third? All right. I'm not going to take credit for that. That's Ashwini's. That was one of the first presentations I saw on the UDM. I think it was in TechEd in 2005 in Australia, the Gold Coast. And it really does reinforce the point of the importance that attribute relationships need to be correctly defined in order to have an optimized experience, both from a processing point of view and from a querying point of view. Far too many examples, thanks to a really poorly designed wizard in 2005. Anyone remember it? First of all, select your dimension tables, and by default, all columns are selected to become attributes of that dimension, and their hierarchies are enabled, and there was no encouragement to even consider that attributes needed to be defined or relationships needed to be defined between them. And so Microsoft support were getting extraordinary numbers of calls that this cube will never finish processing. It just keeps going and going and going. All right? And then at query time, if you could manage to get that cube processed, you had similar problems. That this cube that was promising high performance is just not delivering. Again, often the fault was attribute relationships were not defined. So it's really, really important to be familiar with this theory. So let's work through it. First point, only define relationships where they do exist. This will be the case for natural hierarchies, like what we see here, from country to state to city. Cities belong to states, states belong to countries. This is a natural hierarchy. So there's a world of difference between what the wizard might detect, particularly if you're building this off a single denormalized table, it has no concept that there are relationships between the columns in that single table. It's your responsibility to provide that in the design. So the fact that we have city, country, and state as columns in a single table, and city happens to be the primary key, this is the best that it can do. As mentioned earlier, all attributes must relate to the key, but not necessarily directly. So the appropriate design here would be that we reassemble them to say city relates to state and state relates to country. And then you'll note that that warning icon and squiggly disappears, that best practice alert that's there to warn you that if you're building a multi-level hierarchy, it's likely to be natural and therefore there should be attribute relationships to support it. Do take care that the key attributes truly do mean that this is natural. For example, if perhaps a better example would be if we went down to zip level and zip was the lowest level. The fact that you have Springfield, Illinois and Springfield, Massachusetts, you'd want to make sure that that city's key column wasn't built just on the city name because that's not natural. It would really need to be the unique combination of state and city before that could become natural. Once that sinks in, you really do begin to grasp the concept of what a natural hierarchy is. And so that is a problem that I've picked up, is that while the best practice alerts are saying, hey, you should build this hierarchy like this and support the relationships like this, do make sure the key columns are in fact defining things correctly. Otherwise, when you go to browse the cube and you usually pick it up, that things look bizarre. Things process, but things start to go missing because what happens at processing time is the first relationship it finds, Springfield belongs to Illinois. And you wonder where Springfield, Massachusetts has gone. So it usually does come out at some point, and that prompts you to rethink the design. The key attribute for state isn't correct. All right, so that's the important takeaway. The good news in the 2008 Designer and Forward was they introduced an attribute relationships tab that provides graphic representation of what you have designed in the dimension, and drag and drop, you can go ahead and do otherwise. Now, do not define relationships for unnatural hierarchies. So this example on the employee table, for whatever reason, you've identified an analytic requirement to navigate from department down to gender, down to employee. Now, is there a relationship between gender and department? Well, you'd guess not. Probably unlikely. And so leave it as is. Even though the best practice alert is here begging you, do understand this is unnatural. It's okay. It's there to support a particular requirement. It will not perform as well as a natural hierarchy, but that's the way it goes. We build this to improve the navigation experience for our end users because we know that's how they answer their questions. And then we come to the relationship type. So having established relationships between attributes, there are two flavors of relationships. Flexible, which is the default, and rigid, that you can then choose to configure against the default. So it should be changed to rigid when it is understood that related values will never change. Now I do place in parentheses here, I don't really care. If this is a cube you fully process every night, and we have cubes that are that small, it doesn't really matter. The concern here is that in larger deployments, you're looking for strategies that will support incremental processing and updates of dimensions without disturbing the existing facts that have been painstakingly and time-consumingly accumulated. All right, the moment you perform a full process of a dimension, it resets the internal identifiers of our members and therefore invalidates all of the partition that we have. So often it's very, very important to preserve all of that investment we've made in processing. Okay, so the point here is that if you're going to fully process your database every night, who cares? It doesn't matter. They're going to get reset. This is not a big deal. But in those situations where you cannot afford that full process every time, you have to be careful. Now, usually not a problem if all your changes in a dimension are type 2. Because what happens when that salesperson moves from one territory to another? It actually results in a new record. It's not an actual change within a record. We're inserting a new record. It's actually an add of a member to the dimension. So type 2 changes aren't really impacted by this. It can be a serious problem otherwise, as if you define a relationship as rigid and a change does happen, the only way to get around it is a full process of the dimension, which will invalidate your partitions. You'll have to reprocess them as well. So the benefit of doing this, because why would we? What's the benefit for this potential disastrous cost? Well, the benefit of defining rigid relationships is that incremental processing may not invalidate existing aggregations. What it's doing is preserving all the aggregations that support the querying of the cube and the efficient querying. So if you've got a customer that moves from one city to another and you have aggregations built around city, you can understand that if a customer moves from San Francisco to New York, that aggregations are now going to be wrong. All right, so that's what it's doing. A rigid relationship will provide very strong hints to the engine that those aggregations can stay as is. Now be careful, even if you know that it's illogical that San Francisco, California should move to San Francisco, New York. That just never would happen. But the problem is that humans make errors. And it might well be that they've inserted a record and they correct it the next day with the ETL process fixes it. And while it should never have happened, it has. And so what I suggest is don't play around with this property unless you know what you're doing. And you really need to squeeze more performance out of your processing. Leave it on the default. Understand what it does. For the date dimension, I think you're probably pretty happy that quarters don't move between years and months don't move between quarters. Probably happy to leave that as rigid. But if you're even slightly unsure and you need to preserve all the investment you've made in processing of your fact tables, leave everything as flexible. If you get to that point where you need more to squeeze out, start to come back and reconsider. So we're talking about these attribute relationships. What benefit do they really have and why? Well, they reduce the cube space. If you don't have relationships between the attributes, essentially the cube space, huge as it is, becomes a Cartesian product. So if you want to think of country, state, and city, and let's just use the US states and cities, essentially it's a Cartesian product of every city and every state. Now, as you can imagine, it's illogical that you will ever store a value at San Francisco, state, New York. So that's why we create these relationships, and it knows then to reduce the cube space to what is possible. It improves processing performance. Fewer relationships between attribute memberships are needed. If all attributes relate directly to the key attribute, there's an enormous number of relationships that it needs to define between them. However, if cities belong to states and states belong to countries, there are fewer relationships to support within that line. So not only does it improve processing performance, it improves query performance. Hierarchies are materialized to disk. The query engine has hints as to how the members will be browsed, and aggregations can be created around the relationships. It also allows defining member properties. And if you need to sort members in one attribute by another, for example, my general ledgers aren't sortable by their key or name, but they're sortable by another related attribute. That's another purpose of relating to attributes. And then this one isn't so obvious, but it's just as important. So if you create a security role in your database that says only these users can see New York, but you don't have a relationship from city to state, well, they could go ahead and look at the cities. But implicitly, it's understood by the engine that if they can only see New York, they will only see the cities related to New York. So that's an important one. Other challenges with dimensions, disabling hierarchies. All right, this was the problem in 2005. Let's default that every column is an attribute hierarchy, and that was the case. Next, next, next. We really want to minimize the number of attribute hierarchies that you have in a dimension. Each hierarchy increases the cube space. If it needs to be, it needs to be. But in the most simplest example, if you have like an employee dimension and you have a gender attribute, so let's assume we just have male, female, and of course an all member. Simply by adding that attribute hierarchy to the dimension, you have tripled the size of the cube, or the possible cube space. Now don't let that frighten you, that's just what the product is capable of doing, but don't make it do things that are unnecessary. Do not include attributes that are unnecessary. Do not enable their hierarchy if it's not necessary. So for example, if I want phone number, if I want email address to enrich the reports I have, by all means add them as attributes to the dimension, but do not enable the hierarchies to support browsing by that. It doesn't usually make sense to aggregate sales by a phone number. Okay. Removing the OR level is another classic. I really discourage this, and there are really few times when it really is justified. So there's this property on an attribute hierarchy called isAggregatable. It's by default true, which says you end up with an OR level. This allows you then not to filter by it effectively. You're slicing by the OR member, not by a particular member beneath it. So all gender rather than male or female. The situation is sometimes, though, it doesn't make sense to include an all member. The classic examples would be a scenario dimension. I have actual budget forecast. I don't want to add the measures of actual and budget together. That is nonsensical. So sure, is aggregable? False. Currency in certain situations also. I don't want to add currencies together because they're non-additive. You must choose a particular currency to slice by. So just be aware that when you remove the all member, some unusual behavior can surface. Or unexpected is probably a better way of putting it. And that unexpected behavior is that when you're slicing, when you're querying data and you do not explicitly introduce a hierarchy into your query, either on an axis or in the where clause, then it's still having a role to play. And the role that it plays is the default member comes in. In the absence of an explicitly defined default member, it uses the first member that it finds, which should be almost always the all member. In other words, I'm not filtering by it. The moment you remove that all member, it's choosing the next first member, which could be male, female, or whatever. And unexpected to the user that's actually interpreting the query result, it's slicing on something that they didn't even introduce into their query. So you have to be very, very, very careful about this. All right, so if you do turn is aggregable to false, the next property you're likely to get involved with will be defining a default that is intuitive. All right, so for example, if I'm going to turn the currency all level off, and perhaps we know that 99% of the time it's US dollars we're querying by, we'll default to US dollars. I have a question here. Okay, the confusing nature of what attribute hierarchy enabled means. Well, the fact is your dimension is a collection of attributes. By default, when this property is set to true, the dimension is a collection of hierarchies. So it truly is a hierarchy. The fact that we have multi-level hierarchy simply says that those members could become the members of a level of a multi-level hierarchy. So I'm not sure if that makes it clearer. But truly, your dimension is a collection of attributes that are hierarchies. In the old version of the product in 2000, a dimension was a single hierarchy. And what we have now is the richness that a dimension really is a collection of related hierarchies. Okay. All right, so defaults. Get involved with defaults really only if they're intuitive, and please inform your users about them, because unbeknown to them, it might be slicing on a country or a group or a gender that they're not even introducing into a query. So I suggest that they shouldn't be there unless they really make sense. Better, you can define them at role level too. So you might define it at role level and say the American users and the European users, set them there, or at the reporting layer. Reporting services, for example, if you have reports, use defaults on report parameters if that's, if that's what you're really looking for. Despite the best practice alerts that were introduced in 2008, don't get too carried away with hiding attributes. This one annoys me because those blue squigglies come in and say, well, now that you've used this attribute as a level in a multi-level hierarchy, you should be hiding it. Why would the user want to go to it direct when they can navigate via the levels of a multi-level hierarchy? The annoyance for me is that if you're building reporting services reports and you want to build a report filter that includes the available values, okay, and I've turned off year, quarter, month, and date, but I've given them the complete fiscal hierarchy, sure. In reporting services, it provides this huge list to choose from. And unfortunately, the graphic designer doesn't support working with hidden. I think it should. I think there should be this little checkbox that says, show me the hidden attribute hierarchies. All right, so bear in mind that end users might still need them. So what you could do is create a folder and put them in a folder so that it might be tucked away, but leave them visible. And then go and dismiss those alerts. Say, thank you very much for your wisdom, but I know better that they are required to support more efficient report design. And then despite the dimension wizard's best intention, when creating snowflake dimensions, and this is another annoyance on my side, what it does is it assumes there's a lack of integrity between the multiple tables that form the snowflake. Okay, so what it does is it turns on at dimension level the unknown member. And it's there to support, if there are missing members, then we can assign facts to those, and you end up with this unknown member sitting in there. The annoyance with this is that if there is in fact an integrity problem, it will mask it from you. the dimension will process, and unbeknown to you, there's a problem down there and you don't know about it. So my suggestion is, unless you're aware of that problem and you intentionally want the unknown member, go ahead and turn it to none. That will require you to also go to the key column source property and update its source to null processing, from null processing to automatic. This way you can learn about integrity problems in your data and can fix it there, or at least address it in logics and views. Consider using the unknown member feature when building a UDM on a data source that has known issues, perhaps an OLTP database that has integrity problems. I would rather you fix it at source level or DSV level than compensate for it at this layer. Okay, time for some demonstrations. Okay, so I mentioned my annoyance with AdventureWorks in that it insists on, when you take a look at my date dimension, so the calendar quarter here, I've been forced to uniquely identify the instance of the quarters by using a composite key. Inefficient. All right, likewise for month, I've had to use calendar year and month number of year. So my suggestion is in your date table and other tables, whether it's the city-state combinations, come up with a unique identifier for it, and that will be more efficient in your query writing and query performance. So we come to the date table. And my best practice would say that you would create a view for this. I'll be consistent, but I'm just going to do something a little different here. This will just become my calendar quarter key. And it's pretty much the matter of saying just grab the calendar year, multiply it by 10, and then add the calendar quarter. And while I'm here, let's create the month key. This time multiply by 100 and then add the month number of year. I'd prefer this was materialized in your table. And now I can switch back and I can improve and optimize this design by using that single key. Okay, which then brings me to a related table. So the sales quota does the same thing. I don't like this design either. Having a primary key of a surrogate key on a fact table doesn't really make sense, in my opinion. A date key, that's fine, but persisting the year and quarter here, that's to support bridging at quarter granularity. So I'm going to have to modify this as well. I'll convert this to a named query, get rid of that primary key. It serves no purpose for me here. And I'll go ahead and just introduce a calculation here that is the calendar year multiplied by 10 plus the calendar quarter. And then alias that as my quarter key. Okay, so that's one improvement. The product dimension, this list price. Let's browse it to understand what I have here. So I have this multi-level hierarchy that supports navigating from product category to subcategory to product. That's straightforward. And then color, because sometimes we need to filter on what color our sales were. But then when it comes to list price, I just ask you, what value does this deliver to a cube? Go and give me the sum of profit by products that cost $2.99. But then users will argue, but I need that. When we build reports out, I need to include the list price in the report. Well, that's fair and reasonable. And all we need to do there is simply come in and say, well, don't produce a hierarchy for it. Turn it off. You'll note that it's now disabled. When I right-click and deploy, we now note the absence. That hierarchy is not there. We have reduced the cube space. We have more efficiency now. But if we want that list price, then at product level, because as you'll see here, list price is related to product, is that we can, using this browser, introduce the list price to see that the value is indeed stored there, and that's how it will be available to us. So in Excel pivot tables, right-click on the member, add, I think it's member property, and it will be there, and it will enrich the pivot table with this property. So to move on to create an entirely new dimension, so I have my employee here. Let's go ahead and create a dimension based off it. Note that it's a snowflake because I'm relating to sales territory as well. So basing off the employee table, and this is where my employee, the version name, remember I created that calculation that includes the validity of the start and end date in there? Because the primary key here represents a version, not the employee itself. I often see this confused. Type 2 changes on a dimension says your primary key is a version, not the employee itself. So that's what it's asking. Your key attribute, what is its key column, and what is the label that will be used to describe it. Next, we detect related tables. Let's create that snowflake. And then the opportunity to rename the attributes here. Then I'll bring in this. So this is really going to be called the employee. I call it the employee version. So this one really is the employee. When you build an attribute off the business key, the source system's primary key, this will support discovering what this employee has done everywhere, whereas the version will tell us what they've done in a particular sales territory for a period of time. For certain analysis I need to know when they were hired. We're going to then interpret how many employees we have, but this is where I can disable the hierarchy. So the wizard supports many things here. Attribute hierarchy enabled false here. Login will be great for dynamic security later on, but I don't need to browse by it. And email address and phone number are requirements for my end users to complete their reports. Gender, fine. Salesperson flag, sometimes we need to filter by this. End date I need for my statistics analysis. Employee name is there to support the name column for this. I need to come back and configure this later on. And then we get to the attributes that come from the snowflake table. The lowest granularity of this table is actually region, so I'm going to call the key column region, and then I'll just introduce the group and country, and I'll take this opportunity to rename them. So just as a tip here, it might seem obvious through the progression of the folders here in the project that you would create data source view, and then create your cube. Don't. Create your dimensions first, and then come back, use the cube wizard then to assemble a cube from existing dimensions. The problem you have is that the cube wizard will do the absolute minimum to create the dimension for you. In other words, it will create a single attribute based off the primary key of the dimension table. And then you've got a lot of manual work to do. But as you can see here, configuring the key column and its name, renaming attributes, selecting attributes, disabling hierarchies of attributes. The third column here also supports setting the type property. Next, finish. And here we have it. Just to point out to you, attribute relationships look like this presently. When we go ahead and construct a multi-level hierarchy, so from group to country to region, down to the employee versions of the lowest granularity, this is where we start getting these warnings. And to hover over the tooltip here, it's telling me, best practice alert says, attribute relationships do not exist between the levels in these hierarchies. And this is confirmed by switching across to this tab. Because of course in that second table it has no concept that there are relationships between the columns in the one table. Thing is, we should know our data enough to know that country relates to group, and that is the correct sequence that we should have. Should I mark these as rigid? Any risk that I might have to fully process my related measure groups? Well, I think it's probably a safe bet that that's rigid, and this one as well. AdventureWorks only have 11 regions. I can't imagine we get that wrong. What about this one here? Is it flexible or rigid? I wish I had a prize, but I don't. This is a good question. Thank you. It's a rigid because it's a type 2. If an employee changes sales territory, it results in a whole new record. So we are guaranteed this will never change. And so we can make this one rigid as well. You want a prize? I Oh, it was beautiful Tropicana fruit juice. Unopened! Come up and get your prize at the end of the day. So I can comfortably make that one rigid because I understand the usage of this table and the way that the slowly changing dimension type is working for this table. All right, and we notice those warnings have disappeared. Let's provide a better name for this. I'm going to call it simply the plural of employees. And then we can go ahead and create another one. Sometimes we need to analyze by group to gender to the employee version. What do we do with this one? Do we go ahead and create a relationship between gender and group? Best practice alerts is encouraging me to. All right, this is an unnatural hierarchy, so we just leave it as is. We accept that. That can be tough because it's telling me to do something. All right, so when I go ahead and I deploy that, best practice alerts will kick in. We'll see a list of warnings, and this is your opportunity then to say, stop disturbing me. Well, it should be. Where's my warnings? View, error list. Attribute relationships do not exist. Yes, and I know why. Document here for your colleagues when they come to discover your efforts. Okay. And it'll stop telling us about it. And then as far as the levels that are being used here, sure, okay, so long as we don't need them in reporting services reports, let's go ahead and start hiding things. This one often gets confused. The difference between attribute hierarchy enabled and attribute hierarchy visible is just a visibility thing. Hierarchy enabled is actually removing the hierarchy from the cube space, right? Or from the dimension. So that should solve that problem. That'll be fine for now. I was going to show you what defaults would do, but I think time's going to help me out today. But I was just going to put a default and say, let's default on North America group, and just show you that queries that don't even include group are going to show us North American, whether you think it or not. All right. Moving on from dimensions to cubes, so including many subject areas in a cube is often area for debate. Again, adventure work seemed to encourage us from the early days to create this one entire unified dimensional model that consists of multiple measure groups of all the subject areas in the organization, from finance to HR to sales. Well, the reality is you're making life difficult for yourself. If you can understand that measures between those measure groups are not queried together, then they really shouldn't be there. The first big problem you'll discover is the development effort. That working inside the analysis services project doesn't support multi-user development at the same time. So if you want to then distribute the effort across multiple developers, only one person can have it checked out at a time. And that's often reason enough to suggest we have separate projects, separate databases, and we work like that. We might copy objects like data source views. And there are approaches using linked dimensions and measure groups that can get around other issues to support reuse of objects. But generally speaking, I don't think it's a great idea to have this single cube that includes many, many, many measure groups. Okay, so consider more databases or more cubes. Consider smaller subject-specific cubes. And perspectives are another approach to consider in the Enterprise Edition, whereby you say, well, really, the thing is we do need it all there, but it is overwhelming for the end user to find what they're really looking for. Well, perspectives have been intentionally designed for that. Instead of connecting to the cube, we connect to a perspective that provides a limited view of it, just these dimensions, attributes, and so on. When it comes to distinct count, so this is a pain for any OLAP system. Just the characteristic of what you're requesting with a distinct count can be place a burden on the server, and it can't use aggregations in the same way that additive measures can. So the optimization here is, and it's fully supported by the design tools, is the creation of a distinct count measure will create a measure group to support it. Just keep that single measure in that measure group. That will result in partitions dedicated to the storage of that measure. Format measures appropriately. That's more of a tip. Understand the enterprise aggregation functions and when to use them. So there is a none. Almost seems strange. When would I use none aggregation? That's what a cube's for. By using none aggregation, it says you have to be at the very granular level of the measure group to actually see the measures. By account is there for special arrangements with general ledgers. You can define general ledger types within the project. Average of children, first child, last child, non-empty, and so on. These are semi-additive arrangements. So when my bank balance in January is 100, in February 200, March 300, I'm a good saver. My quarter one is not the addition of those three, right? It's not 600 as much as I'd like it to be. It's usually, almost always, the roll-up of the last child. My quarter one balance will be the March balance, $300. Okay, so the requirement for these is you simply have to define the measures using these types. Of course, you have to have enterprise addition, and you must have a dimension in the cube that has the type property time. All right, you will get errors if you attempt to build a cube that doesn't have this. Consider carefully the need to use non-regular measure group dimension relationships. So while they're there, they will add, some sophisticated modeling capabilities for you. So the reference factor many to many, we're not saying don't use them, but just be aware that there can be prices to pay for their use. Referenced, I generally prefer not to use referenced. The AdventureWorks example is we have a separate geography dimension, and it is referenced via the customers to get to internet sales, and it is referenced by the resellers to get to the reseller sales. And that way we could use this one dimension to analyze the sales across seemingly unrelated fact tables. The big problem I have with it is that you cannot build a single hierarchy across attributes from multiple dimensions. And often what you want is country, city, state, reseller. Maybe it's a small thing. So I typically just repeat the data in my customer and my reseller dimension. Up to you. Many to many is something you can optimize. We don't have time to talk about that today, but there is a white paper that I reference at the end. And there are some tips on how you can improve the performance and optimize for that relationship type. Okay, so adding a distinct count measure is pretty straightforward. Give me the distinctive products, and there you can see automatically creates a new measure group for it, and it's just a matter of naming things appropriately and formatting. Done. Working with different granularity. So we have date here. The sales quota is actually at quarter level. So the good news now is a calendar quarter has a single key column, and that maps across to that quarter key that I defined in the DSV. Okay. And that now means that when we analyze by date, and we take a look at our sales, and we take a look at the sales quota, all looks good. We can come down to quarter level. But what happens when we get down to month level? You're really in, I won't say forbidden territory, but you just shouldn't be there. You've told the cube that it's quarter level data. What can it do when someone requests the month of it? Okay, we can come back and solve that problem in a minute. Here's an interesting problem we've got. So what I've got here is some pretty interesting MDX. That is leveraging the properties that I have in my employee dimension. Well, it should. I must have named something different. Hold on. So it's looking for a hire date and an end date property of my employee version. Let me just make sure I included it. Bum, bum, bum. End date, hire date. Wow. This tested perfectly about 2 a.m. this morning. All right, let's just assume we can see the values here. Bottom line is, what we're doing is some pretty involved calculations at looking up properties from this employee version. So we were basically saying, oh, for the month that we're slicing on the rows, go ahead and do a comparison with, or do a filter of all of the employees that meet a certain condition. In other words, that they were employed during this period. What we're trying to do is come up with a statistic here of headcount. And this is the multi-dimensional way of thinking. The fact is we have captured this data to answer this question. Hire date and the end date will support discovering per month how many employees we had. And this is where I ask you to think outside the square and inside the cube and think, well, that's really not very efficient. Retrieving properties is quite inefficient anyway, internally from the server's perspective. Casting them to dates and performing comparisons on the fly is just really expensive. Surely we can prepare, calculate, or at least partially calculate this data in advance. And the answer here is to say, well, let's go ahead and construct this new fact table that's really a view. And there's some pretty interesting calculations going on here as well, but essentially what it's doing is it's doing a cross-join of date and employee, producing my date key and employee key, and 3 columns of hire flag, leave date flag, and employed flag. 1 zeros is what it's computing at the combination of each month and year. Each month and year, each month and employee. Let me just show you the result. Oops, this keyboard's F5 is in a different location. All right, so we end up with this. And now we can simply build a fact table off this. And we've got far more efficient querying off the measures that we're able to produce in a new measure group. All right, so I can switch across to the cube and the DSV and say right-click, add remove tables. We have down here fact employee statistics, so I introduce it. I convert it to a named query. And I say the employee and the month and the date key are actually the logical keys. Create some relationships, so that's not absolutely necessary. And then I can switch across to the cube design and introduce this as a new measure group. Voila. I don't want the count, so I get rid of it. And then I like to show these in grid view so I can multi-select, and then in bulk, update their format property, and then deploy. So now I have the addition of these employee statistics. So we can then break down across time how many were employed. Okay, but you might notice something a little strange going on here. You know, it's thinking for 2007 we have 2,565 employees. Really not the case, because the measure that we have here, the fact that they're employed, is semi-additive. You can't add it across time itself. It's a snapshot in time. That's how many employees we had in January, February, March. All right, so this is where we switch its aggregate function across to say, roll up its last non-empty value. Okay, and that's going to introduce a new problem you'll see when I go to build. Because it says you don't have a time dimension in this cube, and that's poor design on our side. This is important for the date dimension at least, is that you go ahead and configure its type property so it's known to be a time dimension. And the easy way to do this is to launch the business intelligence wizard, use the define dimension intelligence wizard here, and say that this is a time dimension, and I have date, month, quarter attributes. Essentially, that configuration is setting the type properties of the dimension itself and the attributes. So now, internally, the cube understands. This is how time works for this model. And now I'm in a position where I can go ahead and deploy. We'll switch back to our cube browser. So remember here we had this unusually high figure, and now we're getting the correct results. Cube calculations, so that's the next step. Once you've got the physical data source flowing through appropriately to create dimensions, attributes, hierarchies, measure groups, and measures, we can now play in the virtual space. And that's what the MDX script is all about. So understand the model requirements and define calculations and scoped assignments appropriately. Design the dimensions and cubes to support the required calculations. Consider, as I've already demonstrated, pre-calculating or partially calculating values down at the data source or DSV level. Okay, time permitting, I would go and show you how I could simply add a new column into my UDF. Profit is sales minus total cost. Go and update the DSV to include that column, and then add it as a measure. No need to modify the partition definitions because the UDF with the select star is just going to work automatically. Reuse of that definition of what that table needs or that measure group. General tip here, limit nested calculations. Calculations based on calculations based on calculations can end up in performance strife. Consider offloading complex calculations to user-defined functions defined in CLR assemblies. Know your MDX and the capabilities of the cube's MDX script. And know how to test the efficiency of the MDX you write. There should be an entire session dedicated to this type of event. If you think that's important, let the organizers know for next year. Excellent document here, particularly for beginners to this space, the SQL Server 2008 Analysis Services Performance Guide, full of good wisdom about appropriately using the MDX script and defining cube measures or calculations, and be creative. As an example, read and learn from David Shoyer's A Different Approach to Implementing Time Calculations in Analysis Services. Now, I'm not suggesting this is what you would need to do, but it really opens up your eyes to the potential of the virtual space in a cube and the power you have as the creator and destroyer to decide what happens in this virtual space. By the way, the Business Intelligence Wizard's Time Intelligence feature is there for novice developers. So while it can create year-to-date calculations and so on, David will point out to you why his approach is better. There are many limitations assigned to the wizard's way of doing things. Okay. Time doesn't permit. That's a shame. But we'd love to show you just a scoped assignment. You know, when we went down to month level of the calendar quarter, I could easily just assign a scope that says, if you're in this part of the cube that is defined by a member from the month level of the calendar hierarchy and you're in the sales amount quota measure, then don't show that value. Use the parent member of the calendar hierarchy's value divided by 3. In other words, go and grab the quarter and divide by 3. You have full control. In a planning situation, next year's forecasts are actually equal via a scoped assignment to last year's actuals multiplied by a 10% increase. It doesn't have to come from the source data. And just as a tip, I had a customer that was very proud to show me this utility that supported end users injecting into the MDX script. I said, are you joking? I said, end users that aren't happy with the values they see in a cube can inject scoped assignments to override anything. You really do need to protect this MDX script and not make it available for others to add what they need into it. Cube enhancements, actions. So I did have a great demo, but time won't permit. And essentially, it goes like this, that the requirement for a drill-through action to deliver the details you want, those details are going to need to be in the cube. And often what you need in a drill-through are values that link back to source systems, like a sales order number, tracking number, or something. The moment you introduce this level of granularity into a measure group, what I would demonstrate is, it's quite cool, but time won't permit again, is that it doubles the size of the storage of the MOLAP cache on the file system simply by including the sales order number. Now, if your only requirement is to include a sales order number for drill-through purpose, the consideration there is to use a reporting services report to drill through and have the reporting services report receive the context of the drill-through cell. You can pass in the member keys into report parameters and then have a reporting services report generate that data for you. It is a bit of work, but the trade-off is faster processing, smaller cube disk space usage, right? Perspectives, useful to focus the user on a specific subject area, can be helpful to limit exploration in performance point analytic grids. All right, so if you want to, people ask, how can I limit the drill-through options that they have? Well, a perspective. Base the data source on a perspective and build the grid off it. I'm presenting on Performance Point this afternoon if you're interested to see more on that topic. And keep in mind, these are not designed to enforce permission sets. All right, often confused. Beginners think that we can assign users to a perspective. No, you can't. It's there to support exploration. Final topic then, security. Define roles accurately. There's nothing more annoying coming back and seeing roles that are really not well defined because you don't know whether they're still in use. Can I drop them? I guess I could and I might hear about it. All right, so use the description property to use that as a log or to provide detail as to its purpose. Avoid cell level security. It comes at a high cost. usually you'll discover that just by allowing or denying members in dimension hierarchies, you can achieve what you're looking for. So think carefully about that before you get into the cell security story. Now, this is the big challenge, and I've got 1 minute left to talk about it, but Analysis Services only supports Windows authentication. The challenge here is, what about non-Windows clients? Ultimately, a Windows account is going to have to connect, but if it's important then to ensure that the end user only sees what they're allowed to see, there are a couple of techniques that you can get working with. Now, if it's not an issue with non-Windows clients, you could solve this problem by using Kerberos delegation. The identity of the end user requesting this report, reporting services will take that identity and pass it down to Analysis Services, and then according to the roles that you've defined, they'll get to see what they can see. The problem is, in some organizations, it might be difficult or impossible or politically hard to get Kerberos delegation up and running. So your next approach is that you can configure dynamic security expressions. So available to you in MDX that you can then use to define and allow or deny members in security roles is the username and custom data functions. And the username returns the domain name /username. So that would be appropriate in situations where you haven't got Kerberos delegation, but you can authenticate the user, perhaps at reporting services end, and pass. No, hold on, that's custom data. I'm getting confused. Username is good when I've got a login attribute in my employee table, and then I'm going to compare. I'm going to say only allow this user to see themselves. In other words, I create a set function that will limit the members of the employee hierarchy based on where the login ID matches the user ID. That's a way of saying the user can only ever see their own data. The situation where I can't authenticate the end user against the data source is that I can pass some custom data, and then I can use that in expressions to then determine what they can or cannot see. And an extension of this can be using UDFs that I might have, in a sense, tables that govern what you can or cannot see. So the data isn't in the cube itself, but passing the custom data into a UDF, I can then query the relational database, have it return a string that represents a set of members that you're allowed to see, and then back in the role definition, I convert that to a set, and then that's how you implement dynamic security. So you know what? I got there. I had more demonstrations. I do wish I had more time. It is hard to plan for this. So that pretty much brings us to the end. The other session to complement this, as I've said, was yesterday's, that we'll talk more about partitions, aggregations, and processing. So please, if you missed it, look out for the recording. Recommended books, Data Warehousing Toolkit. I think the Expert Cube development with Microsoft SQL Server 2008 Analysis Services is an excellent book if you're moving beyond the basics, as is the Unleashed book that'll take you well into the internals of the product. And I think pretty much there is the SQL Server articles, so the performance guide, distinct count optimization, many-to-many dimensions, and identifying and resolving MDX query bottlenecks. While these are written for 2005, largely still applicable to the current release of the product. Other resources, BIDS Helper, free, download it from the community sample site. Extend your capabilities to enrich your cube design experience. And that David Scheuer article is available from this link here. Great, so what's next? Well, it's all up to you. I hope this promotes you designing more optimized cubes and dimensions. Thank you, we look forward to your evaluation.